Next example, example 6, we're going to, again, analyze the critical points of this function. In other words, figure out at each critical point, do we have a local min, max, or neither? So we begin by taking the first derivative of the given function f to obtain x squared minus 2x plus 1. And now this right here, this should factor into x minus 1 quantity squared. So, because this is, again, a polynomial, so it's differentiable everywhere, we know that this exists everywhere. There's no value of x that we could plug in to break this, to make the derivative not exist. So that means the only possibility here is that this first derivative must equal 0 if we're going to have a critical point. So we square root both sides, and then we find that the only critical point we have is x equals 1. So make a sign graph for this. Negative infinity to infinity, the real number line, our first derivative, and then we mark down the locations of any critical points and whether this was a critical point arising from the derivative being 0 or arising from the derivative not existing. So here we're going to write 0, not DNE, because we found this critical point by setting the first derivative equal to 0. So now we have essentially split our number line into two distinct regions, to the left of one and to the right of one. So now we just need to pick two convenient sample points within each of these regions. So we'll go ahead and do f prime at 0, which is going to be, well, if we plug in this 0 here, these turn into 0, and we just get positive 1. So this is, we'll just say is positive, so plus sign. And then if we plug in x equals 2 into the first derivative, here we can see in this format, this is just the factored form of that. So if we plug it in here, we're going to get 2 minus 1, which is 1, and then 1 squared is 1, which is yet again positive. So here we get positive. So this is neither a local min or max because we go uphill, but then we continue going uphill. So this just flattens out for a minute and then continues going uphill, sort of like x cubed. And this is a cubic. Now, not every cubic does this, but it does allow for that possibility. So we'll just say the critical point at x equals 1 is neither a local min nor max. It's neither.